In this video, we're going to talk about problem 4.5.4 from section 4.5. Section 4.5 is on solving applications involving right triangles. So the problems are extensive and require some quite a bit of work that wouldn't just fit on top of the PDF. So I'm using the whiteboard. I've copied the exact problem here that I'm going to be working. So recently, about 70 metric tons of soil were removed from under a leaning tower, pictured here, and the angle the tower made with the ground was increased by about 1.1 degrees. Before that, a point near the top of the tower was 47.9 meters from a point at the base measured along the tower. That's this slanted line over here to the left side of the tower, not this vertical line. And this top point was directly above a point on the ground that was 4.45 meters from the same base point. So the 47.9, while we're showing it on the left-hand side, is really over here on the right-hand side of the tower. And we're making a triangle that looks like this. So the 47.9 meters is on this side, and the 4.45 meters is on that side. And we have a right triangle because this is the base is over here, and the tower is leaning this way. I've exaggerated it a little bit. There we go. All right. Now we have this is before, then after. So we're going to change it so that when we increase the angle a little bit, this is, call it alpha. And this is alpha plus 1.1 degrees. The tower doesn't change height at all. So that stays the same. But what is going to change is going to be this side over here, and how much did that move. So and this side may also change as well. All right, let's go ahead and get started here. First, let's use the given lengths with our cosine function to find the angle. So because this is adjacent over hypotenuse, we're going to say that cosine of alpha is equal to 4.45 divided by 47.9. And we're going to say that alpha is equal to arc cosine of 4.45 over 47.9. We're going to make sure that we're in degree mode in our calculator because we're adding 1.1 degrees to this when we're done. So let's find the arc cosine of 4.45 divided, copy error, sorry, 4.45 divided by 47.9. and I get 84.66 94278 degrees. And now we're going to take that and we're going to add 1.1 degrees to it, so that alpha plus 1.1 degrees is going to be called beta. So I'll call this angle over here beta. And that's going to be 85.76942778 degrees. To find the adjacent side here, we're going to use the cosine function and say that, let me move this up now. Cosine of beta is going to be equal to, let's call this side here C over 47.9. And we're going to solve for side C. So cosine of that angle that we just got times 47.9 is equal to C. And I get that this is about 3.53. So let's come back up here and put that on my diagram. Now we want to find the distance that the tower has moved. So we're going to find the difference between 4.45 and 3.53. Is 0.92. And that's in meters. And that answers our question here about how much did the point on the ground move towards the base point. It moved 0.92 meters towards the base point. All right, that is it for this problem. We will come back next time and we will talk about 4.5.7, number 7 in section 4.5. So see you for the next video.